Hello, hello, hello. Oh, I still have the sound on. Hang on. There we go. All right. First day of my streaming schedule, right? In case you haven't seen the update video on my YouTube channel. Hello, Kakalak Joe. I'm gonna be streaming every Monday and Wednesday, 10 a.m. For 4 hours, roughly, I think. My bitrate is apparently unstable again. I'm not sure what that is all about. My internet should work just fine, but oh well, whatever. Technicalities. So yeah, I finally have a streaming schedule that I'm gonna try and adhere to. No longer just like streaming of when I feel like it. Because I haven't been streaming for the past couple of weeks, to be honest, and I'm kind of miss it. Also, one of the things, I opened up a Ko-fi page finally, so if you feel like supporting me, that would be very nice. Thank you very much. I'm not just gonna bang the drum on this one too much, so I'm just gonna close this page. And what I want to do today is, I'll see how far we get, but basically I have this, let me open the old solution. So previously I did all my projects within Visual Studio, but I kind of don't like Visual Studio really. So I figured I just do them in Sublime Text and use command line tools to then build and run my projects, right? So for example, the GB header extractor right here, I have like my build.bads, debug and run.bad files. And just to showcase, let's go to projects, GB header extractor, right? If I just call build, it actually builds the project. If I call run, it will actually run the project. Okay. Oh yeah, this is expected output. Never mind. I can also build it in release mode if I want to by just typing build release. Right now it's actually building it in release mode. And if I want to run the release mode, I just type run release, and it actually will run the release version of the executable. And I like this a lot more than using Visual Studio. And hang on. For debugging, I also have this little debug script. All it's doing, it's basically starting the rad debugger with the executable. And if I debug release, I can debug the release executable, which is quite nice. And I mean, you already saw how fast the rad debugger opens, right? Compared to Visual Studio, it's just such a nice tool to work with. And I kind of like Sublime Text a little bit more to type as well. It just feels nicer. So yeah, I just want to get away from Visual Studio. So one of the things is I slowly started transitioning all these projects that I had here with like solution files and put them over to like this kind of project structure right here, right? So basically just using the bat files. And so I want to do the same with the GameBoy assembler that I wrote on stream, right? So this project right here, not sure if you can see that, it is quite small. Also quite blurry right now. I'm sorry about that. I'm not sure what's going on with my internet at the moment. I hope it's normal for you guys. Oh no, if I set the quality to source, it just works fine. Never mind. So okay, I want to transfer this over, and another thing I want to do is I just not only want to transfer it over, but I also have this obsession at the morning. At the morning, yes. Good morning, IO means live. This is Mondays all over again. I also have this obsession with like building projects at the moment without the C runtime. So I will be also removing that. So also no longer using WHRT and all this kind of stuff. Hang on, this is not even... Oh no, this is the assembler. All right. Let's close all tabs for now. Just open main. Yeah, so basically also not using the C runtime library because I do not like it, and I rather have my own implementation of things. And then, so essentially because of that, because I'm removing the C runtime, so no more heap realloc and all this kind of stuff, right? So it is also going to be essentially a rewrite, because what I also want to use instead is like my little danlib right here, which I have. At the moment there is not much in there, but there's basically a C file that is called msvc no crt. This is basically all the stuff needed to make the compiler happy. So in order I can compile with without the C runtime, right? So I have this C file that is provided right here. Hello. And then what I also want to use is arena allocators. So I have this Dani arena here, which is basically a memory arena. And yeah, if you want to learn more about memory arenas, there is this nice blog post by Ryan Fleur. I probably butchered that name. But yeah, if you just look for the Hidden Grove blog and Google for like arena allocator, then you'll probably find it. It kind of explains all the intents behind it and things like that. And I made my own implementation of what he's been writing about here. And I kind of like that approach towards memory allocation. So I'm going to use that as well. So yeah, that essentially means it's probably going to be a rewrite for the assembler. So yeah, let's just start with creating the project, and then probably the first thing I'm just going to translate is the tokenizer. So for the lexical analysis, right? The lexer, essentially. I just call it a tokenizer. And because this one doesn't really have any form of allocations, as far as I remember, because it's literally just going, over all the bytes in a file and then spitting out tokens out of this. And this can probably be largely unchanged. Yeah, I don't quite like these, but whatever. Yeah, I'll have to think about it. I mean, I probably put the tokenizer in an arena as well, so it's not on the stack anymore. This GBA file, I don't know if I want to keep that. We'll see about that. And I thought I disabled my notifications. Sorry about that. Let me do that. There we go. Okay, so yeah, I think the tokenizer can be largely unchanged. So, and then I basically will copy over one file after another and slowly try and figure out how to do this without the C runtime and slowly try and build it out from there. One of the things I definitely want to change is the symbols table. Oh yeah, the font size will be bigger once we switch to the, so here, I think that should be okay, right? The on Sublime Text. This is where we've spent most of our time in. I'll just open this. I mean, I can scroll in if you want to, but we're not going to be spending too much time in Visual Studio. So the symbols table I definitely want to change because right now it's a bit of a mess, right? And I don't quite like what I've done there. Parser maybe as well. We'll see. I mean, I have a few new features that I wanted to add to the assembler as well, like the ability to have basically arithmetic operators like plus and minus at least. I realized that is quite helpful for addresses, for labels. If you want to subtract one label from another to like get the size of some data within your assembly and stuff like that. All right, but let's just start with creating the project. So I'm just gonna copy the GB header extractor, lazy, and call this GB assembler. right? And then we just remove the things that we don't need. So license, readme, source, to do. I mean, the to do we can leave in there. We don't need the ROM. We don't need the build folder. Bam. Source. Sure. I mean, third-party STB we're probably going to use because the printf is pretty cool in there. We don't need IO. We don't need, whoops, we don't need GUI. We will need the Danilib for the no CRT and the arena stuff. And it also has the header with my basic type devs and stuff that I use in every project. And then base, you know what, let's just remove all that, even though I probably use string, but definitely want to leave console in there because I want console output, obviously. Yeah, that should be all right. And then we have all of these. Okay, cool. So, GameBoy assembler. This is our to-do file. Let's just keep this open. Run. So the executable will be called GB assembler. I just need to change the name on all of these. Right. We probably... Do I need user 32 lib? I mean, probably, but we don't need the comctl. This is still correct. Yep. And this is the flags for... Yes, for no C runtime. Okay, cool. Subsystem console is also correct. Right, and let's go to main. So we pull in the windows.h, which is fine. We have the implementation of this one right here. Default memory commit size. Sure, we have Danilib in there, so we don't need these. We do need console. Don't need these. We don't need GUI. So program start, set up the console, that is fine. Have an exit code. The basic one is exit code success. Where is that defined? Oh, in program.h. Fine. Let's remove these. And we'll probably want to change this to assembler. Right, this will be the actual program code. Right, at the moment we don't do anything. Probably can print out something just to make sure. Print hello world, right? I just have to check how my console functions, how they work again. I don't remember. Oh, we'll figure this out. Okay, so then we have a memory arena that we allocate. And it's going to be 8 megabytes of reserved size. And we're committing 4 kilobytes. And we have an 8-byte alignment for new buffers. That is fine. So this will be like the memory arena that is basically living for the entire duration of the program lifetime. Think of it as just, allocating a huge buffer on the heap up front. So we're allocating actually 4 kilobytes, committing, but we're also reserving 8 megabytes in total in address space. So if we ever go over the 4 kilobytes and need a bit more space, we're just going to allocate, however much space we need, up to a minimum of 4 kilobytes, and it will just use the address range of this 8 megabytes in sequence, basically. Okay, read command line options. We don't have that yet. So to do read command line options, this is like the very last thing, right? Even on this assembler version, I haven't had command line options yet. I just had like hard-coded files, which is probably what I'm going to do as well. So yeah, let's not worry about this. Set up option paths. No, this was also with command line. And then we just run the program, pass in the arena, and return an exit code, and then we exit the process with set exit code. So this is basically like, you know, emulating kind of what the C runtime was doing, setting up a few things in before the program start. And this program run, you can basically imagine, is like the main function, right? But instead of argc or argv, I just pass in a memory arena. That's basically it. Right, then we have console. So what do I have here? I have setup console, which is fine. So what does this do? I have these global handles. So we're getting the standard handles for the console. If anything fails, we just exit the process, like pretty hardcore, all right? But I mean, that's fine. Something seriously wrong if we don't have these anyways. Then we set the console code page to UTF-8, as well as the output. But we write the last Windows error if that fails. So where is this defined? That is also defined in console, which is excellent. Okay, so what is last Windows error? It gets the last error, which is a Windows function. Perfect. And then we pass it to write Windows error. Okay. We're calling format message A and letting it allocate a buffer, which is fine. And then we have a fixed buffer right here, which is okay. It's for an error message. I don't really want to pass arenas around for error messages, because if there's an error like this, we'll probably terminate anyways, right? If there's a Windows error. Yep. What else do we have? Write last Windows error and exit. And that requires an arena. Why did I do that? String format list. Ah, this needs string functions, right? Okay, you know what? I'm gonna comment this one out. It might be useful, but I'm not gonna use it right now. And then we have this stuff which uses the string. Maybe I should have left the string in there. Now I'm gonna rethink this. So I'm just gonna comment this out for now, and let's just write something to the basic console, right? So write console A. Let's just do program.c. Sure, let's write it to the error handle, and our message is gonna be hello world. Why not? Right, and strlen hello world. I think this needs to be a D word though, right? I think. Okay. cd gb assembler build. What? Ah, I'm calling string format buffer here as well. Okay, I should have left string in there. Okay, no worries. Let's just put string back. Why not? It might be useful anyways. So projects, GB header extractor, base string, and we want this in GB assembler. Whoops. Source space string. Fine. Okay, what do I have here? So string basically is just the type def for this. Sorry, not the type def. It's this struct, right? So I can just use str. Basically, what this is, it's unsigned char, basically. So, well, not char. Let me show you the actual base. It actually uses this, which is Microsoft compiler specific, but it's a fixed 8-bit wide type. So anyway, so it's using this, which is the base pointer, and then I also have the length in there. Okay, so, and I have sort of like a constructor kind of thing, right? Then we have string format, which is formatting a string and putting the result in the arena, so it's allocating it on the arena. I have string format list, which is basically the same thing, but uses VA list. This is one of the only things I use out of the C runtime, really, and that is because it's still quite useful. STB is using the same thing, right? Yeah, there you go with stdarg. And those headers you can just use without having to rely on the C runtime. It's just basically some type defs and things like that, so it works just fine. And then I have string format buffer. Oh, right, this is when I want to actually have a fixed size buffer and then just use that instead of the memory arena, so I have that one as well. String literal const to C string, and is string equal. Okay, I mean, those are kind of useful. Assembler, right? There we go. Okay, then I can put these back. Might as well just leave them in, whatever. Okay. No? What's wrong now? Oh, right, of course, I don't even include it. Okay, so I also want to include the base string.c. So the way I program my C programs is a bit different. I always just include the C files because I don't like multiple compilation units. The only time I really do that is with the MSVC no CRT thing, because of these pragma functions memcopies. Because this basically says use this memcopy implementation throughout the whole compilation unit. So I don't want to put this in the main compilation unit. That's why I put it in a separate one. But yeah, it's just nicer to have it like to just have one compilation unit and not worry about, you know, multiple C files and specifying them in your program output, like adding all of them in here. Where is it? There you go. I just have to add the main C, and then I have this no CRT C file here. It's just personal preference, really. And I mean, I don't really need those header files right here, right? I could just use the C file in general, but sometimes I might use some of the functions before I include the, you know, the C file in this main right here, so it's probably going to be out of order or whatever, so it might still be useful to have the header file around, so I can just include that one in one of the C ones. That's basically just the only reason why it exists. Okay, so now build. What? Execute console not defined? What? But it's right here. Okay, this is not string, this is gonna be console, sorry. Yeah, that's probably why. Right. There we go, okay. Arena, unreferenced formal local parameter. Not local, I don't know where local came from, I just made that up. If I include C, do I declare all funcs as static? No, not really. Don't really need to because it's just one compilation unit, right? Static only helps if you have like multiple compilation units. I mean, you could just make it static, but it doesn't really matter. Okay. I mean, basically what this is doing, it pretends like you have written everything, right, just in one C file. I mean, this include does nothing special, right? It just really dumps in all the text that's within this C file into this one C file. And then you just compile this one C file. So I'm not sure if there's any other benefits of using static in that sense then. Haven't thought about it much, to be honest. Okay, now this is just a warning because we don't do anything with the arena, which is correct, but I have this unused macro here to get rid of that warning, right? At least I thought I had unused. Shoot. Don't I have unused? I do, but not in all capitals. Man, talk about knowing your own library, right? There we go. Okay, and then just run. And hello world. Okay, cool. So this works. So now we can start copying stuff out of the actual GameBoy assembler project. So token. Let's start with the tokenizer. Let me think about this for a second. I mean, the token itself is fairly simple, right? We have an enum, which defines the token type, and then we have a value. GBA file location, what was that? Oh, yeah, I remember. That was like really hacky. Okay, so this should really be information that is within each token. Because you kind of want to know where this token is defined, right? You want the file the token is defined in, you want the actual byte offset, you want the line number that token is defined, and then you want the column, so the number of characters within that line where the token starts, essentially. And the way I did this before was like I had this file location within the tokenizer, so you could only just request the current file location and then the token. So it was kind of detached from the token, which doesn't make much sense. And I remember it made the code so confusing. So I'm definitely going to change that. Yeah. So really what we want is the token, but with a bit more information. Okay. Wait, what else did I use? So this is the token, fine. I have file, which is just like the file handle. I'm not going to worry about that for now, I think. Tokenizer init, okay. See, like they pass the file location around, which is just so ugh. I mean, that's still gonna kind of be the same though. I think. I'm already thinking of how to rewrite all this. Yeah, like I said, so it's not going to be a one-to-one copy because this is just nonsense. Okay, we can make this a bit nicer. I also don't know if I want to have this fetch and peek, right? So basically the way this worked before, it was just fetching one token at a time, And sometimes I needed to kind of peek into the next token without consuming it and, you know, changing all the tokenizer locations and the current token and stuff like that. Oh God, where is it? Here. So I have current and next, right? And sometimes I need to peek ahead and then consume it and then peek ahead again, and it's kind of like a bit messy as well. So maybe what I could do is have like a token buffer that just fetches I don't know, up to like 8 or 16 tokens at a time. Unless you know, a line of text might just have 1 or 2 tokens or whatever, then I just fetch however many are within that line. Or maybe I should just fetch all of them anyways, and then kind of do like a circular buffer kind of thing, where I just move things around. I don't know. I mean, regardless of that, I can just copy the parsing stuff, because that is more or less the same. Yeah, the source files are on UTF-8. So I have this code point right here. Wait, where is it? Yeah, this checks if we are in a valid code point. So it skips control characters. Where is it reading that code point? Thank you for asking that, because I would have not checked where I actually have the UTF-8 reading. So this is print invalid code point. Okay, let's just go to next token, right? GBA file get code point. There we go. Okay. Maybe I should start with the file reading instead. I mean, this is not like the fastest way of parsing, you know, UTF-8. By no means, but it just works. It's quick enough what I'm trying to do. And later on, if I really want this to be more optimized, I can go in there and actually do some more specific things with it, right? Okay, let's do the file reading. So base, let's have a new folder, call it IO. And a new file, and we're gonna name this one, what are we gonna name this one? Sourcefile.h. Right, there we go. Right. Whoops. I should really have file templates for this at some point. I'm not sure why I distinguish between source files and include files. If that is even necessary, to be honest. Source file is just a source file, alright, so. Don't think I need that file type stuff. Oh, look at that. I already used Windows stuff here. Cool, so I can mostly copy all of this. Well, so I don't like the naming scheme though, although, well, GBL, let's call it source file, right? File name is just gonna be, you know what? Let's make this a string, right? We have a string struct, so let's use it. The file handle, yep. The mapping, why mapping? Did I used file mapping. Does that even make sense? So the thing with file mapping is, right, it I think only commits 4 kilobyte window into the file at first. And then as you read on, it just puts in more of the pages in memory. Which another way of doing this would be to not rely on file mapping, because like I find file mapping mostly only useful if you do like multi-threaded reading of the file, which is definitely not something I'm gonna do. Another way of doing this would be to just have an input buffer and just read, you know, the entire file in memory and just keep it there. I mean, that's essentially what file mapping is doing as well, but like it takes away of me having to worry about the allocation of the whole buffer and everything, essentially. But I can think about that another time. Let's just copy this as is. Okay, so we have the handle, we have the mapping. Size t, that is U64, right? That is the size of the file. And I have a U8 pointer, which is the base. I guess that is the start of the file. And file type, we don't care. Now, one of the things I could add here is the actual location I'm currently in the file, as opposed to maintaining that out of the file handle, right? So let's do U64 position. Yeah. Yeah, that's fine. Okay, cool. And then let's just copy this one and the close method. Let's just take... Yeah. Okay, new file. Let's call this one sourcefile.c. And we include the sourcefile.h and just plonk this in. Now, instead of using those Windows types, I like to use my own definitions because like I don't really like the Windows ones. I have this B32, which is basically a 32-bit Boolean, right? So I'm going to use that instead. As opposed to wchrt, we use UTF-8. I mean, the whole executable is... so the whole process code page is UTF-8 anyways. No, questions don't annoy me. Ask ahead. I might just sometimes not see the questions, so the answers might be a bit delayed, but questions are definitely welcome. By the way, reading a whole file at once is actually not that bad, right? It's quite a fast process. Especially like for parsing, if you just read it ahead of time and just have everything in memory, you're just a slightly bit faster when processing the whole file at once, because you don't have to read up to process up to 4 kilobytes and then wait for the operating system, to map the next page into memory and then read on from there and then starting to map another page. And then, I mean, at some point they kind of map multiple pages, but it takes a while. I mean, probably should measure the performance of both ways, either to see what's faster with the file mapping or just reading everything at once. But that's something I can do later on, right? It's not something I need to worry about right now. Yeah, I don't know about memmap on Linux, sorry. This is C17, I think. Let's check. Yeah, C17, but I'm not using the C standard library at all. So I'm actually compiling without it, so no default lib. And yeah, so no fopen and things like that. I'm using directly kernel 32 functions that Windows provides, and that's about it. So it's not going to be a portable program, but I mean, Windows is my main operating system from now on anyway, so I'll worry about porting stuff when it comes to that. I'm not really... I don't really use Linux, so, I didn't really care to make it portable. Okay, so file name can also be a string, right? We have the string type right here. File type, not needed. And then I'm returning the file structure. So this will be on the stack, but I kind of want to keep the stack clean, right? So what I can do is use an arena instead for this one. So let's do that. This would be... I forget the type names, man. Memory arena T, there we go. So there we go, we have an arena. And instead of a boolean, we actually return the source file type as a pointer, right? There we go. File open read only. I don't like that name necessarily, so let's say GBA open source file, because that is what we're doing. Okay. This is your opportunity to run Windows, exactly. I'm also still learning it. I'm very new to it, to be honest. I always used higher level abstractions to, deal with all this kind of stuff. I'm coming usually from C#. So, yeah. And now I forgot how to use my arenas already. Isn't that fantastic? Don't need a new memory arena. What I need is get memory arena buffer, right? So I want this one at some point. And let's see, can that fail? I think it can fail, right? Yeah, it can return 0. In which case, I'll just exit the process. Okay. So handle, actually, yeah, I wanted to do that as well, sorry. Handle is actually just a void pointer, right? So let's just make this a void pointer as intended. I don't like those Windows type defs. They're just confusing. Okay. So let's just open the file handle first. Right. And you have to call create file for that, which is a bit unintuitive. I think I have a macro called cstring to... no, that would be in string.h, wouldn't it? I called it toCstring, right? So basically what this is doing, it takes the string structure, takes the base and converts it into a char pointer, which is what a C string usually expects, instead of having this unsigned 8-bit integer right here, right? So, where was I? I'm all over the place. Okay, there we go, toC string. And then we still want generic read, that is fine, yep. Null, I forgot what that parameter is. Open existing, if it doesn't exist we fail, right? And null, excellent. So, create file. Okay, I've already done this here. It returns an invalid handle value if the handle is actually false, right? So if the file open failed for any reason, we do this. And what I've done here is just print a Windows error and then yes, and make sure it's null terminated, of course. I don't really like doing this here. I mean, I could essentially just put asserts in here, you're right. So I don't like really defensive programming and checking all the time. That is something that will be done on a higher level. So if a user inputs a string for a file, then I make sure it is a correct string and everything like that. But as we go further down into the methods, I just plunk in asserts really, just to make sure it doesn't fail in debug mode, and then I just leave it out because I don't like these defensive checks within my own program. I only really check whatever the user passes in is correct. Everything else, I don't care. But yeah, what we can do is we can make sure that arena is not null, right? And what we can do is file name. So first size is bigger than null, right? And we can check that file name base is not null. There you go. And the cool thing about this assert, I mean, that's how assert usually works as well, but I kind of, because I'm not using the C runtime, right, I had to kind of do this myself. But this assert is just this macro that if you are in debug mode, it asserts always, right? It calls the assert always macro, which basically is like this do while statement where it checks, well, if whatever statement we pass in is not true, then we trap, and trap is just basically calling debug break, which is an intrinsic for the compiler to then, break and give you the opportunity to step in with the debugger. Otherwise, in release mode, it just, it will just be removed, essentially. We're casting it to void, the compiler will remove it, it's all good. No checks necessary. Okay. So instead of GBA print Windows error format, let's look in console, because I had this write last Windows error and exit, but I probably do not want to exit right here, right? Do I want to exit? So how can this method actually fail? Let's see. So it fails with a Windows error right here if we have an invalid file handle. We call get file size eggs, which can fail with a Windows error. So we call that. This is our, okay, so this is our own error. If the file size is 0, it's an empty file. We're just going to say, hey, you're trying to compile an empty file. It doesn't make sense. And then we have other Windows errors right here. I was trying to see if I can put the printing of Windows error outside of this function, but I might as well just write them in here. Okay. And I also need to close the file if something failed, right? I mean, technically, I do not need to close the file because if this fails, the process fails, and then Windows takes care of closing the file handles anyways. So in theory, I could get rid of that code. And maybe I will. We'll see. Honestly, probably not a bad idea to just get rid of the close file handle here. Whatever. The whole assembler just runs for the duration of one source file anyways, right? So it's not like this is an IDE that needs to stay open. Yeah, go-tos, exactly. I usually would have like a cleanup here, right? And then just say, okay, if whatever, go to cleanup. But I'm wondering if I should even bother with this at all. Probably not, but anyways. Okay. Yeah, let's just write last Windows error. Or should I also exit? Yeah, you know what? If this fails, it fails, right? Let's just go hardcore and just just fail. Okay, so we pass in the arena, we pass in our format. What is our format? Well, we have failed to open file percentage. I like to do the count s though. And how is this? I apologize. I need to figure out how my own functions work. Okay, so we're getting the last error. We're formatting the string list first, writing that out, and then write the Windows error. And that will have a new line attached to it. Okay, so this is essentially just a prefix. I should have named it prefix then instead of just format, but hey, whatever. So what we want is like something like this. Okay. And then we have file name dot length. Thank you. Length and file name dot base. Okay. So then I'm getting the file size, which is, yep. Okay, we just pass in the handle and file size, p large integer. Jesus Christ. Okay. What is large integer? Where is it? Windows data types. What? Doesn't exist? What? Oh, there's an extra page for large integers. I see. How did this work then? Wait, was this a large integer before and I didn't see it? No, it was size t. How did it work? Yeah, so for file biggest than 4 gigabytes, I mean, that will be quite an achievement to have an assembly file that's 4 gigabytes, right? I think the largest ROM on Game Boy is like 8 megabytes. I think, if I remember correctly. I mean, I could look it up in the header extractor, right? I mean, nope. Input, I think. Yeah, 8 megs. So how big would a source file be for an 8 megabyte file? Let's just say like maybe 100, 200 megs, I guess. If you count all the characters. Conservative estimate, I suppose. Okay, anyway, so if the... Yeah, let's so what I need is a large integer, right? File size. And then this will be the address. Yeah, I mean, this is an assembler for Game Boy, so for Game Boy ROMs. Oops, I need this one. Okay, so this is the address of file size. If that fails, fail to get size of file, fine, sure. And let's not worry about closing because this will kill the process anyways. Cool, so we open the file handle, we know the file size. Now we can have the check of the actual file size, right? So if file size is 0, then we're just gonna say, hey, you're trying to compile an empty file. I mean, we could have like a max file size, right? I'm not sure if I want to do that, but we could basically say, hang on, what is the... I need quad part, right? That's the part. File size dot quad part. Oh, it worked because it's a union. I didn't see the union. That's why. So, right. And because I'm using 64-bit, it always uses the quad part anyway. So, yeah, okay, that's why it worked. Duh. I could have a max file size in here, right? So quad part is bigger or equal to max file size. And then we can define something up here. Let's say define max file size. I don't like that I prefixed everything with GBA, you know. Let's remove that. That is kind of nonsensical. It's not like I'm writing a library code, right? Yeah, let's remove that. It's just the source file. Okay, so max file size, I don't know. Let's say 1 gig. This macro right here, so for Gibbs, is a macro in my little lib here as well. Where is it? There you go. What it's doing is basically it's taking the gigabyte value that you pass in here and converting that into bytes. So it's just handy macros. I have that for kilobyte, megabytes, gigabytes, and terabytes. So at the moment, we don't allow file sizes bigger than 1 gigabyte. Seems alright. Oh, but that should not go into the same if. This will be different, right? This will be here. File size, quad part, bigger or equal to. Yeah, I copied the whole thing. Duh. Okay. And there's no write last Windows error for it, but I can just print out an output, an error string, I mean. So let's do that. And I do have string literals right here. Right? Yeah. So, wait, but I don't have a format. I need to use string format. Ugh. Okay, let's use string format then. String format. Okay, and we're getting an arrow string. Arrow string, right? String format. We pass in our arena, and we have this format right here, and the format will be empty file. Percent $s, and this will be file name. I cannot type today, as always, and file name base. Actually, source file is empty. Right? And then we can just say write error string, and we pass in the error string, and there we go. And I'm not trying to think whether exit process is actually the right thing to do here. I should probably do that one step. But I kind of want to get the last arrow value out of these, right? So here it seems right. Down here, I'm not sure. Whatever. Let's just exit. What kind of arrow code? I don't know. Some of those arrow codes are reserved up to this one. So what would that be? 15999. Okay, you know what? Let's just, I don't know, A, B, C, D. Just for now. To do get proper error code, right? And the same goes for down here if we're bigger. Source file is over 1 gigabyte. Actually, yeah, bigger than. Okay, cool. So now I need the file mapping. and then the viewpoint of it. So definitely copy this up here. So, and then we can say we have a void pointer that is the mapping. We pass in the handle. I'm not going to check those parameters because I think they were all correct to begin with. I don't like using those macros, so we just pass in 0, 0, 0, 0. Well, yeah, I suppose it doesn't really make sense, but we can just be nice. Also, I don't know if I really want to stay on file mappings, to be honest, so I don't know. I might redo this at some point. So we have last Windows error again and failed to create mapping of file. There we go. Right, delete that. And then we have U8 base, where we pass in the mapping and the file size quad part. Whoop. And then if base is 0, we do this again, but say fail to map file. Okay, so this is the whole file open, and then what I want to return is the source file, right? And I want to allocate this on the arena. So I kind of need a buffer. Right, and what we're doing here is pass in the arena, and we need the size, and the size will be size of source file t plus file size. Nah, we don't need that. Right, I was already thinking of like reading the file into like a thing, but we do the file mapping, right? So I don't really need that. I really just need the struct itself, so it's just going to be that. Then source file t file. Let's just cast if file is 0. And I know I already checked, but let me refresh my memory. It can only fail because of Windows issues, so if virtual alloc fails or anything like that, otherwise it would never return null. So in that instance, then what I can do is again write the last Windows error and just exit. Right. I don't know. Okay, then file name is this. File type we don't have. What we do have now is all of these. right? So file handle is the handle, file mapping is the mapping, file size is file size quad part. Then we have file base, which is the base right here, and file position, which is just 0 for now. Okay, I kind of like the spacing. And then we just return file. Okay. Let's just name this open source file and put this in the header. There we go. And I probably want the same for close. This can just be a void. I don't really care about any failures there. Source file T, right? What on earth? Really? Okay. File is not null. And file base is not null, right? And file mapping is not null. And file handle is not null. Okay. Do I exit the process if file closing fails? I mean, not really. Why would I close the process if file closing fails? So let's assume this is like an include file. If the include files fail to open, yeah, just close the process because like there's no point in parsing any further, right? But presumably I call file close just after let's say I passed in an include file and then just continue with the next file. If I then close the file and it fails, then do I care? Not really. I can print out a warning. But even then, do I care? Not really. Yeah, you know what? Let's just... yeah. There you go. I do not care. Right, I can set these specifically to null. Mapping and file handle. Do I care about the position being null? I mean, I could do that, but then I also need to set this. Basically, set everything to null, right? That's like so much unnecessary work, to be honest. Do I really care? We'll see. For now, it's in. Yeah, I could use memset, right? I'm just debating whether all this is really necessary at all. So there's that. Nah, fine. You're right. I always forget though. What is it? Destination, whatever I want to set it, and the count, right? Okay. So file will be the destination. We want to set it to 0, and the count is size of file. There we go. So this is open source file, then close source file. Yeah, for sure. It will definitely remove unused code, that is true. Let's just not worry about it. Let's just leave it here. It's fine. If it's there, no harm done, right? Whether I call it or not, it's a different story. I mean, I probably will call it for the test right now. So let's do that. I had fixed input and output in the old program, so let's just reuse those as well. Right, so let's remove this. But instead, this will be U8. Actually, no, you know what? This will be string t, right? And then we can say this will be string literal const. And we're gonna do that. Literal const. So input and output file name are just gonna be hard coded for now. This is stuff that I've already used before. Actually, do those files even still exist? Before I just assume, right? Sublime. Where are they? GameBoy assembly. Well, it looks like they no longer exist, do they? It's in here. Just Game Boy. Okay. And it's program.gb and program.gb asm. Okay, is there actually something in there right now? Yeah, will you look at that? So this is like an Hello World application. Well, this will... No, I don't have a Game Boy assembly highlighter here. Well, sorry. But essentially, this is what the previous Game Boy assembler already could do, right? So I had aliases, so I could have basically like defines in C sort of kind of thing, right? Just with fixed numbers. Sections, no, those are commented out. That didn't work. But I have labels at least working. Yeah, there you go. I had no arithmetic for labels, which was annoying because down here is the tile data. So this is the beginning of tiles. And then we have tiles end. And I know, like, I kind of counted it myself to know exactly the size of it, but it would be nice if I could just write something like tiles end minus tiles, and that gives you then the number that you need to use. But that is something for later, right? I'm just trying to get exactly the same thing working as before, just with nicer code. So we have input and output file. And let's just see if we can open the input file for now. The source file with these new functions right here. So on program C, we have source file T, which we call source file, right? Open source file, we pass in the global arena that we're having, and then we can just say input file name. And then we can look at it in the debugger, and then close source file, we just pass in source file like so. Cool. So build Interesting. Oh, right. Of course. I have not included IO. What is it called? Sourcefile.c. There we go. Size is not a member of string, is it not? No, it's length. Fantastic. Love it. Where did I... There we go. It's length, not size. Okay. What? Line 4? Oh! Oh, no! Okay, fine. Length is not a member of source file. Right, because this I have named size. Good God. Undeclared identifier search file. Yeah, that would be correct because that looks like a spelling mistake. Where is it? Ooh, what? Ah, yeah, there we go. And output file name is not used at the moment. Yes, fine. Okay, let's comment it out for now then. Shall we? Okay, cool, run. Fantastic. Debug. Step in. Okay, then we go here and break here. And then we look at the source file. Cool, so we have a handle, we have a size. 9781. Okay. I mean, it seems kind of right? 9781. Yeah, there you go. So we open the right thing, and then we actually have the base, which looks like the code at the beginning of the file. Fantastic. And position is 0. Cool. Okay. What else did I have in file? So now we can actually get to this part where we read the file code point, right? Yeah. So let's copy this and put it in the sourcefile.c. And we're also going to need all of this stuff right here. Yeah. Let's just put that in the C file for now. Okay. I32, let's make this a U32. Oh no, I did make it an I32 because of the invalid sequence, which would be -1. Not ideal, but whatever. So read, let's call this read code point from file. We pass in the source file. We don't need the offset because we have the position of the file. We actually have it stored in the file struct. And we also don't need to pass in the output position. See, this is what I mean with messy, right? So in before, I read on the current offset and then calculated how far to advance the pointer, but then returned it out of this function to then later use. It was a whole kind of mess. I do not like this at all, so we're just going to have that in the struct itself. Okay, we can make a quick assert. File is not 0, right? Do we care about handle and stuff? I mean, we can say file base is not 0, maybe, because that is what we're accessing, really. And then there's also the issue of, okay, invalid sequence, but if we're at the end of file, we kind of want to be nice about it as well. I mean, that can just be 0, right? Yeah. Okay. That makes sense. Let's remove the GBA stuff and then end of file. Nope, not equals. Dear Lord. Yeah, I do not like this GBA prefix anymore. Let's just remove that. Okay, okay, okay. And this is the maximum code point that we can use. Fine. Okay, file base is still valid, but instead of offset, what we're going to use is, for now, let's just replace this with file position, right? So, and what we want to check if file position is bigger or equal to file size, then we just return an end of file. So this just increments the position right here and returns it. Then this can be plus equals 2. And these can also be plus equals. Yep. Right. This is just getting the size, and then I have another check right here. I mean, okay, fine. Don't mind. File position. Ah, no, but then... Bugger! Okay. Let's call this new position. Right, and then new position, and then we have new position, I think it's just bigger than, right? No. Yeah, okay, so this is correct. Smaller than new position. Okay. should be alright. I mean, this already worked before, right? So I'm not gonna worry too much about it. I just need to make sure that I don't screw up like the position stuff. But I mean, I'm getting the size as a new position right here. So I'm calculating the new position essentially, right? And then I'm just incrementing the file position and reading the next byte, starting from the next byte before because we already read the first one right here. Right, and we're already doing the necessary things here, and then we check is continuation. Oh, I also need to remove all the GBA prefixes right here. There you go. Oops. Yep. Okay, so this and these two defines right here should be part of the header. Nah, let's put them here. Okay, and then let's just test this out, right? So I32 code point, right? And then code point equals, what did I call this? Read code point from file, and we pass in this source file. Let's be explicit, right? Can even do this and the file, whatever. And we're just trying to read like through the code points now. Just get one code point after the other. Don't really want to print them out. But what we can do is check the position afterwards and see where we are in the file, essentially. Yeah. Invalid code point, right? Just plunk in an assert. Okay. What's up now? What are you complaining about? Oh. I no longer named it I32. I named it S32 for sign32 instead of I for integer. My bad. Right. Yeah, I32 undeclared identifier. That is true. So this is in program C. This should be S32. There we go. Invalid code point. Did I not name this invalid code point? I named it invalid UTF-8 sequence. Okay, how about invalid code point? Right? I like that better. Okay, run. Okay, so debug. Do I still have it open? Fantastic. Yeah, let's just see what happens when I step in. Text, does that work? No. No, not U8. How about char. Does that work? Nope. How do I do this? I don't know how to debug. How about now? Cool. Okay, so code point is the right character right here. And then let's just hello world. Yeah, okay, so it can actually get code points. Now it would be interesting to see what happens if I put in, like, I don't know, Chinese characters or whatever. We can try that out in a second. Okay. And then position. I wanted to check the position, didn't I? Ah, damn. I mean, there you go. It actually works. So position, if it is bigger or equal to, and it is actually the same as the size. So we actually reach the end of the file and we get out of this loop. So that just works. Fantastic. I could now do like, okay, let's put in a Unicode character. Why not? What should we put in there? Anything interesting? I don't know. How about a smiley? Can I just copy one? There we go. Right, and then we just need to run this. There's a UTF-8 test file. Interesting. Where can I find it? I don't know if links are allowed in this chat, but if you just roughly write, then I can Google it or something. Okay, so we have... Okay, let's not make this a char. Let's just print out the actual code point and let's print it out in hex, right? So because the next one should now be the... Oh, I accidentally jumped in. Ah, that's okay. There we go. We have a quad code point. And then we are reading it. And we're returning it. There we go. 1F600. Is that correct? You can't see it, but there you go. 1F600. So that works. There is probably some edge cases or whatever. I mean, probably need to test this properly with some kind of input at some point. But let's just move on for now. No, I did not test for valid ranges. I think I'm doing this in the tokenizer itself. Right, I have this is call point valid. And this is where I'm like skipping control characters and things like that. And then just check for the max UTF-8 call point right here. That's about it. I don't do any other validation so far. Might add that later on, but that's gonna be okay. I mean, I could, given that I do this all the time together anyways, nah, it should be part of the tokenizer. I don't want to make this part of the file reading. I need some water. I mean, so this whole assembler leads a lot more scrutiny anyways with like testing and things like this. This is something that I've started in, oh gosh, December? Or November? Something like that, last year, right? And I just hacked this out on stream, essentially, just trying to make a basic assembler working. But I have not gone through the lengths of like testing and verifying everything, right? I will definitely have to do that as part of this new project. But like I said, I really dislike most of this code anyways. That's why I wanted to go ahead and like basically start it from scratch. But yeah, there's a lot more rigorous testing that needs to be done with all of this. It's just not going to be the focus today, honestly. If I'm actually getting the tokenizer out and working again in this new project structure, then I'm actually quite happy already for today, to be honest. Okay. Right, so this is the file reading out of the way at least, and I like this much better with the position actually stored in the file handle. That is quite nice. I can later on add some other methods of like, you know, rewinding the file position or whatever, or things like that. But I mean, rewinding, you just set the position to whatever you want, right? It's like, okay, it gets a bit more complicated when you want to rewind in code points, but yeah, it's fine. I don't think I actually ever will need that for this project at least, so it's okay. Let's go ahead with the tokenizer now. So all of this. Okay, so I do not have to jump back and forth all the time. Let me just copy all of this and put this in the new file and then just comment it out, and then we just take stuff from what I need, right? Let's make a new folder and call this... What do I want to put in there? All the parsing, all the tokenization, so the Lexa and things like that. I don't know. Let's call it assembler. Assembly. Nah. Parser. It's a bit... Nah. Parsing. It's part of parsing. Sure. Parsing it is. New file. Just dump in all of this, and this will be the token.c. .c, yes, we want the .c. Tokens. What did I name this before? Just token. Fine, token.c. Okay. We don't need this. Okay, let's just comment everything out. And then use one by one what we need. New file. I want consistency, so why did I name this one? Okay, fine. Sorry. Shoot, where's the open file? There we go. Damn it. Token.h. Okay. I mean, the token enum is probably gonna stay the same, right? So again, do not like the prefix here. So we have an end of file token, new line, white space, comment, separator, indirection, number, label, directive, identifier, and string. There definitely will be more to add later on. Like I said, I want arithmetic stuff, so plus and minus, probably. Maybe some other fancy things. I don't know yet. Let's just get the stuff working that's already there, right? Okay, but then the token struct, I definitely want to expand on that because I want a bit more information for every single token, right? So we have a struct that's a token. And it has a token type, which is fine. Okay, it has a string, which is the value. So what this previously was is it was basically just pointing to the text where this token starts in that file. So value.base would essentially be the very first character of that token. And then value.length would then be it slipped into German there. Oh dear lord. Value.length would then be however large that token is, right? So if it's just one character, it would be just one, or you get the gist of it, right? Those token values would not be zero terminated. Which is fine because in the way I use them, I never really had to have them zero terminated, but it would definitely be an issue when passed to like, you know, standard library function. But we're not going to use them anyway, so it's fine. But I wonder if that is even good to have like that. So see, what I really want is like the byte offset, so I can add that for error messages as well, right? I want to see where in the file it came from. And I could calculate the offset by using value.base and then, you know, minus the file base, and that would give me the offset. But that means I have to do pointer arithmetic all the time if I want to have the offset, and I don't really like that. So then I also want the line number this token is at. And I also want the column. So which kind of the character number of within that line, right? Just to get an idea where it came from, essentially. Then I don't know if I should have the file name in there as well, so I know from which file this token came from. I'm not sure that is really necessary, because as I'm processing the tokens and holding on to the token data, it is within one specific file anyways. And if then there's an include file at some point, it kind of switches context to that include file and processing them, so I know it will be in that include file. So I don't think I need to have the file pointer in here at all, but I definitely want to have this kind of information here, right? So offset really is just the position, right? The position within that file. I have a line, the line number, and I guess the column. Fine. Now, because I already have the byte position, I'm not sure I really need this string value right here, because I can build a string out of this. But what I do need is the length of that token, right? Yeah, that should be okay. No, I don't have to switch to Visual Studio anymore. I need to get that out of my head. Okay, then we have this tokenizer struct, which was holding on for the context, but let's ignore that for now. I think I'll just start copying these things right here. So this is where I check for the valid code point ranges. So what are these defines here? Those are the actual characters. Oh, that was nonsense. Yeah, I mean, those are useful to have, right? Why do I need to expose them? I mean, I'm exposing everything anyways. It's just one C file, right? But okay, let's just put them in here. So this will be, oh my lord, token character, or just char. Let's do that. We also want to include token.h, and I also want this to be in here, right? So what we do is include parsing token.c. Right, I have all these code points for like white spaces and new lines. That can definitely be done nicer at some point. Let's not worry about it too much. Let's just call it token CP for token code point, right, instead of char. There we go. Okay. So the first function to deal with, do we even have a valid code point? Is code point valid? This will be S32 with a code point, and we have a B32 for Boolean, right? we no longer have this. Instead, we named it token code point. Okay. Oh, right, yeah, CP underscore, you're right. Thanks. Oh, gosh, in a lot of them. Ah, no! Damn it! Up there as well. Ah. Thank you for noticing. Max UTF 32 count point. I think I named something else, right? Well, it's here, but let's put this in the header as well. I kind of dislike that this stuff is in here, to be honest. This here is more like something that should go with the other code point functions, right? Because we have read code point from file and then. But I mean, I only use these functions in here anyways, so whatever. Let's just leave them in here. It's fine. It's fine. It's fine. It's fine. It's fine. Let's not worry too much about this. Okay, then I have like a few more of these helpers. So basically, is code point new line, right? Okay, you know what? Let's replace them everywhere. Ah, and there's the type in between. Curses! Whatever. Token CP. No, that's not quite right. I cannot replace all of them. Sorry. Fine. Let's just do all of these functions, and then I replace those tokens all at the same time. So, okay, this is fine. We have a code point is digit, and that is just purely ASCII digit. No, sorry, B32. Okay. B32, and then we have the same like so, and funny how I had one typo here. Okay. token CP. Okay, these can largely stay the same. I'm just going to rename them a bit. So say is code point white space, is code point digit, is code point token. Typo on line 35. You're absolutely correct. Man, you're on it. Okay. We can build. That is fine. So then I also had a print invalid code point error. So if anywhere in the file I had a invalid code point, I would print an error message. And then what would I do? I would return false. Okay, this is probably better to follow in Visual Studio just to get a sense of how the error handling worked, because I do not remember. Okay, so let's see. Let's say we try to find the end of a white space, right? We're getting the next code point. We're checking if this code point is valid. If it's not valid, we print whatever error and return false. Okay, so where's this called? In here. So we're just propagating false. Love to see it. This is tokenizer peak next. Okay. Huh. It appears that if I had an invalid code point, I was just trying to do the next one and counted up the errors to report an error number at the end. That does not seem like a good idea. To me, if there's an invalid code point, I should just stop parsing altogether. It's like, no, man, what are you doing? Fix your source file first, right? It feels like something that should terminate, really. And that means we can probably change is code point valid to just something that terminates when it is invalid. So this would become something like check code point is valid, right? Just do void, and then what kind of error stuff do I have again? Well, it's not going to be Windows error, is it? But I can use string format and just write out the error like so. Yeah, that should be okay. Did I ever use this in any other way? Like, okay, print invalid code point. Do the same here, return false. Print invalid code point, false. It's the same pattern throughout. Okay. Oh, but then I need an arena. Fine. It is terminating anyways. Might as well just put an arena in there. Arena. I mean, I will use the arena a lot of times anyways, so that's okay. Okay, what was the error message that I usually went for? I printed a file error. Right, I printed... I see. Yeah, again, so this really seems like something that should go up here. Right. Decisions. Let's just do it this way. Right. And then we call this one right here. And I can then later decide to move this stuff around if I wanted to. But for now, code point, right? And then, okay, fine, let's take this. And then let's not heck around too much. There we go. And we're just gonna call this one and just... I can later try and merge that pattern together if I wanted to. But check code point is now right. Is code point valid? Right. Code point. Otherwise, error string format. Yeah, good point. Good point. Read valid source code point. That is true. Okay, string format arena. Then yeah, okay. Invalid code point in actually the file errors. I kind of had a specific structure to them, so I kind of want to do the same. It was kind of like this, right? So it has the file name, then it shows the line, the column, and the byte position within that file, and then it just has the error text. Right. I should probably have an error function like this, to be honest, that writes it as a file error. That's probably not a bad idea. Yeah, okay. Right, file error, and we have a memory arena, and we have what you mean in a comment? In a comment block within the assembler or within the assembly? Yeah, you could. I mean, I hope. I haven't tested, but it should work. Actually, whatever is behind the comment, and if it is within the valid code point range, I just accept anything, because comments get ignored anyways. So what did I remove? Okay. Actually, I don't know if I want to put the right file error in here. I might just put it in here. Error message. So let's think about that. So do I need to be able to format stuff? Probably. Right. Okay. Right. I need asserts, fine. Nope, not these. That is fine. Let's just copy this for now, real quick. Where was I? There we go. Okay. I don't need to assert the arena directly here because it will actually be asserted by string format lists, so I can just ignore that. I need to assert the file, so file should not be null. And yeah, no, that's fine. File should not be null, and format should not be null, right? So then we have the var args, the list. We start the list based on the format. And then we format the list, right? Okay, so this is the... let's just call this the message. So this is the actually message we want to write out, right? Not sure why there's a result. We don't need that. And then I need to do this part right here. Where I actually prepare the file name, the line, the column, the byte. Do I need to copy that one again? No, I can just make 2 calls to, yeah, that's fine. And let's call this the prefix, right? So what we're gonna have here is the file dot, wait, do I actually store the file name? I forgot. I do, thank good. File name dot length and then file name base. Then we have file. But column and length are not right. That is not stored within the file. That is annoying. I have not thought about this too much. So this is the byte offset. That is fine. But I also need the line number now and the column. I could just store it in the source file as well as I'm parsing through it. But that doesn't seem right, does it? Maybe I should. That will be going back to the idea that this entire code, like with checking white spaces and new lines, should actually be part of this source file reading. Because that is like the very basic thing to do, right? Read line by line, essentially, recognizing line endings. And all this other stuff, like directly, all of these tokens here, that is part of the actual assembly language, right? New lines on white space, not so much, I guess. I don't know. I mean, really, I just need to check for new lines. Which is kind of what I'm doing here with is code point valid. Yeah, let's just add it. Column and the line number. And this is the byte offset, so the position. Basically, absolute position, relative position, right? And, well, line position, really. And then the line itself. Okay. So read code point from file should do the whole heavy lifting then. So basically all of that should live in here. And then I can decide what to expose later on. Okay, let's just continue with what I had. So I'm formatting the message, and then I'm formatting the prefix, right? So, and I can actually fill this out now, because now we have the information on there. I'm not really using it yet, but... so we need the line number. We need the column we're at, and we need the overall position. Right? And then I can call this with a prefix, and then make a second call with the message. Okay. So this writes a source file error. Now, let's move this one in here. In the C file, sorry. So we have the memory arena and the source file. We read code point from file. I will copy that. No, so this one is up here, right? But is code point valid? I will copy this into this file shortly, but let's ignore it for now. And then we return the code point. If it is not valid, then we want to write a source file error with the arena right here and the file and invalid code point. And we can actually print out the code point. Why would the user want to know the position of the error? You mean the byte position? Well, to me, it is quite useful. So, I mean, line number and column is kind of self-explanatory, right? If you have a text file and you want to know where the error happened. But if it's like an invalid code point, it might just be that the byte is screwed up, right? So you want to know the exact byte offset of where this is happening. And so you can open it with a hex editor and then just jump into that byte offset and try to figure out what's going on. I wish more tools would report the overall byte offset as well, as opposed to just line numbers and column, because I find it quite useful. But if anything, at least give me a flag where I can enable it if I want to see it, right? Yeah, your text editor is a filter, but like, you know, if you transfer a file over a network and some byte gets mangled up or whatever, and then you just can't read it properly and you want to fix it, I find it useful to have the byte position. Just, you know, just a useful thing to have. Is it just LD? Always forget. I think it's just LD. Okay, and if not, let's just be hardcore and just exit the process, right? To do. Okay. Now this needs to do a bit more because we also need to advance line and what was it? and column, right? So byte position will already be advancing. That is fine, but we now need to check for these things as well. But let's go, is code point valid first? So this one. So let's plonk it here. And then, yeah, I feel like I probably put all of these in there. I should probably have a code point file at some point, but whatever. Let's just this like this code point. So is code point new line, is white space. Probably gonna expose this, is digit, read code point from file, okay, whatever. Is code point valid, right? We're checking for valid stuff. Okay, if it is valid, let's check for a new line. And if it is, then we advance this. We set the column to 0. Well, the column is character-based, really, but that's not quite true. A coin point is not a character, right? So at the moment, the column reports code points. For the time being, good enough. Whatever. But really, column is 0. Line, let's set it to 1. Is it weird that I have lines indexed by zero by 1? No. Let's not think about it too much. That's fine. Okay. So really, I don't want to expose this. I probably also do not need to expose these. This checks if the code point is a token, which definitely belongs to the tokenizer. Don't need this. But I want these, right? I might need them, I don't know. Okay. Right. What did I do there? Source file C. What are you complaining about? Function const S8 differs slightly in indirection. Right, that is true. That should be an S8. Okay. Right. Okay. Forgot some of these. Wait, that is in source file C, yeah. What? Did I not copy the rights? 216. Right. That is CP. Fine. Okay. So, and then what I want to use is read valid source code point instead, right? Read valid source code point. We have the arena and the source file. All right. Yep. I mean, this kind of is not right anymore. Actually, so what if code point is 0, right? Is code point valid? Right. Well, that's not. Specifically for the moment where the code point is 0, which is the end of the file for me, right? So if it is 0, we're just going to go into this branch and return the 0 code point instead of exiting the process. Okay, this asset no longer makes any sense because, you know, I mean, I can leave it in for now, whatever, it doesn't really matter. This is just test code anyways, I'll remove that shortly, but really, it should just run now again. I don't think we have screwed anything up. Okay, code point. There's our smiley face, 1F6000. Okay, cool. Let's just deactivate this one. And then again, size, perfect. Column 1. I mean, what we can print out now, that would be a good test, I guess, is the line number, right? So let's say string format, arena, and then we do line, LLU, I suppose. Source file line. And then write output string message. There we go. 335 lines, which is not correct. Okay. Whoops. So what am I doing wrong? Yeah, but what am I doing? How did I count twice? That's the question. So read call point from file advances the position. That is fine. That is fine and dandy, right?
Sorry, Daniel.
What?
I don't see a pool in your contacts.
Stop. Frickin'.
No problem, I won't.
Okay, note to self. Do not use automated home voice recognition when streaming. Fantastic. Siri here to help, yeah.
To who?
No, stop.
Okay, I won't.
Yeah. I gotta unplug these when I stream. For tab, I counted as new line? No, I don't believe I did. I mean, at least I wouldn't see where. Because, like, is new line, right, is counting this. Wait, hang on. Oh, the new lines are CRLF, right? It's Windows. So this is why twice. Okay. I think I had that with when I'm actually looking for line ending stuff here. Hang on, let me do this in Visual Studio. So wherever this is called, no. How did I handle this before then? Ah. Okay. So if I want to handle CRLF, I guess I have to do it that way. So if it is a con point new line, right, I can make another check if con point equals CP CR, right? Yeah. Then we can just read the next one and can probably do this even simpler. Instead of full-blown calling myself again, let's do this. And if next is not LF, right? So this will advance the position. Okay. File position. If it is not that, let's just rewind. Right. And if it is that, then we're just gonna leave the position as is. Does that make sense? So let's go through it again. So if we have a new line, we check if the new line is CR. if it is CR, we're just going to remember the position we are currently in at the moment. We read the next code point from the file. If it is not a new line LF, we just rewind the position. And otherwise, we just go forward. That should do it. Hey, there we go. And 168, 168. Huzzah! Okay. Sorry for switching back and forth between Visual Studio and stuff. I'm Alt-Tab trigger happy. Right. So, what's next? How long have I been streaming? Okay, I've been streaming 2 hours, almost 3 hours. And I can stream a little bit longer today. So usually I've been planning 4 hours for my streams, but today there's nothing really, much going on, nothing else I have to do. And I really want to get the tokenizer at least like fully ported over. But I do need a coffee. So I'm going to take a little break, let's say 5 minutes. And then can it break if /r/r/r/n? I mean, I don't know. Do I really need to care? That's the question, really. If you have multiple CRs, no, because CR is also a valid line ending on its own, right? As far as I know. Let's see here. CR, I mean, yeah, on old machines. It counts as a valid line ending. So in this instance, okay, line counting might be a bit off. Do I really mind that much then? I mean, there's only so much I need to worry about, right? If this becomes an issue at some point and someone complains, I'm sure I can think about something. But other than that, I would just leave it. I mean, there's also LFCR, right? Which is what I'm not handling at the moment. But like, we're not trying to be 100% perfect here, right? Something maybe later I can fix. But anyways, I will take a 5-minute break because I really need a coffee right now. So I'm just going to make a quick coffee and come back, and then we continue with the porting of the tokenizer. So essentially, in the end, what I want to achieve today is have it loop over the whole file and then print out every single token that it finds. And so we just have the console output be a streams of tokens, essentially with all the token information. That's all I want. It's going to be a lot, but hey, whatever. All right, okay. I'll see you in 5 minutes. All right. my little coffee. Also, I had to eat something real quick. Got a bit peckish. Okay. Nope, don't want you. I want... Nope, also not this. What is with me and Alt-Tab today? I'm really trigger-happy with Alt-Tab. I don't know why. I can't explain it. Okay. So we have the token cone points right here, and is code point token? Or is token code point? No, is cone point a token, right? So this kind of still makes sense. It also makes sense to stay in the token file, I suppose. So I said before that I would like to have like kind of a buffer of tokens, but I feel like that would probably be rewriting a lot of it. In any way, I need a way to read one token at a time, right? So probably something like get next token is still perfectly fine to do. So I'm going to just be doing that. But I want doing like a peak function or something like that, similar like, you know, advance after a peak or anything like that. But just having a function that is able to read one token at a time, definitely useful. So we're going to start from there. And then even if we need to fill up a buffer of tokens, let's say like 4 or 6 or 8 tokens at a time, I'm just going to call that function 8 times, right? Whatever. Should be fine, famous last words. So I think I genuinely had everything like this in the peak function right here. Because fetch was basically just calling peak and then advancing, sort of, kind of, it was a bit nasty, but whatever. So let's just copy this and try to go through it and make it work. All right. Well, it uses a tokenizer and stuff like that, so this is where it gets a bit iffy, but also file location, don't know why I have that even. And then the question is, should I return a token that's allocated on the heap? Probably not. Whoops. That was my 1 hour alarm. I'm sorry. As in 1 hour left in the stream. But like I said, I will probably go a bit longer today. We'll see. We'll see how far we get. I do not necessarily... Apologies. Oh my god. Oh. Right. I do not want to necessarily allocate the tokens on the heap. So not every single token, right? That wouldn't make any sense. Especially if later on I have a buffer. I might allocate the buffer on the heap. That's fine. But then I just, you know, replace whatever is in the buffer. So... I'm not sure if this bool return is really... Okay, so I had this bool return here because my idea was, even if something failed to parse because, you know, it's kind of a wrong token or whatever, or the token doesn't really parse properly, I still wanted to be able to get the next token anyways. So... because you don't necessarily want to fail the whole process just because one token might be slightly wrong, right? Although I'm trying to think, like, when could a token be slightly wrong? I don't really... Yeah, I don't really... Why did I do that? Hang on. Was it really just for the invalid code points? Which definitely is something that should kill parsing, because chances are that the entire file is corrupted then. And I do not want to continue. That is okay. That is like a fatal error, essentially. But everything else, I don't really see why... Okay, let's go... Where's a good example? A comment, right? Why can this fail? Well, invalid... Okay. Everything else just returns true. That's what I was thinking. I don't see how that could ever fail. Okay, let's maybe go through them one by one, right? So let's say find end of white space, right? We just had this one. This just returns true, like unless it is an invalid code point. But again, we just killed the process there anyways. So file next token. Again, false on invalid code point, and everything else just returns true. Man, this is bad. Yeah, I really did not think when I wrote this, did I? End of line. Again, everything else returns just true. Okay. End of string. So this would be a quoted string, right? So GBI code point is new line. Okay, I'm... I see. So I had some kind of validation here for string sequences. So if you would write something like this and then never close the string, right? Let's not do this in the comments. Let's do it in the actual GameBoy assembler, right? So a comment is with a semicolon, and if a string is just this, right? And if I just had a new line and just had one of these, that would fail. So that would print out an error already. But I'm wondering if that is even supposed to be in the tokenizer, really. We could potentially attach some information on the token itself that says, like, I don't know, the token type is a string, but the string is incomplete, right? But then, even then, I don't even know why I need to return false here. Let's see. I don't really. I just go out of this. Peek next. And peek next fails? Why did I... What happens if peek next fails? Do you ever have that when you like look at code that you wrote like 2 months ago and you look at it and you're like, what the fuck was I thinking, right? Pardon my French, but... Isn't that all code? Yeah, okay, fair enough. You might be right there. I mean, sometimes I look at something that I've written 5 minutes ago and I'm thinking, what the fuck? But yeah, good point. But you know, I rather have it this way and then rewrite stuff that I've already written than just sit there and think for like, I don't know how many weeks, you know, to try and come up with the perfect solution and then sketch everything out and then you start writing and then you always find something that you didn't account for. So I rather just start writing, even if it's rubbish, and then just rewrite whatever. Hey, thanks for the follow. Okay, it seems like I let it fail because sometimes I need to peek into the next operand. So if I have a parser operand, so this is during the parsing process, not so much the tokenization. But then I'm returning true there anyway. Okay, this is just a way to indicate like what you got is rubbish. But again, I think I can just attach that information to the token itself. Maybe. I'm not sure if it is a good idea, but maybe just have it as another token type. Incomplete string. Like an incomplete string token. Does that make sense? No, not really. Doesn't really make sense. I think I'll just attach, like with a union or something, extra information to that token. I think that would... let's remove this again. That would probably make sense. Let's clean up the tabs a bit. There was a bit too much stuff open. Okay. So yeah, I don't think I need this bool at all. Like, I just get a next token or I don't get it, right? And if it is the last token because the file is closed, right? Sorry, not the file is closed, but we have reached the end of the file, then it will always return the end of file token anyways. And then, which is right here in the file. Let's just call it retoken. Don't have a tokenizer struct anymore. Don't have a file location anymore. And right, so what do we actually have? We have a source file t, right? That's gonna be the file we're reading the tokens out of, and then the token itself. Yeah, let's just have it as a pointer. That's okay. Let's make some quick asserts. We make sure that file is not null and file base is not null. And we make sure that token is not null. Now, let's figure out what I was doing in the past here. So this is just making sure we're not at the end of the file. But GBA file get code points. So we now have this read valid source code point, and that will return 0 if we are at the end of file. So we can just check for that. And it also needs a memory arena. Okay, so let's put in the memory arena. I can potentially combine these into the tokenizer struct as I had before, but for now, let's just do that. Is end of file here? No, it's not. Interesting. It's really annoying. If I move my desk, there's something squeaky, and that annoys me. Okay, sorry. Right, so I was reading the code point before. I was checking if the code point is valid, and if it wasn't valid, hello again. Then I was stopping. Okay, so I'm reading the first code point. See, this is the whole location thing, which now lives in the file itself, which is much nicer. So I don't have to populate, all this nonsense throughout the tokenizer, which is really nice. Okay, I was immediately getting the token value, which is a bit questionable. Then I was checking for new line. White space. Digits. Now, why was it doing these separately? Whoa. Just wanted these two. Oh, come on. There we go. Okay, new line was just accounting for this stuff. Why not short names like is digit instead of the longer variants? I don't know. I just prefer to be a bit verbose with my function names. It's just personal preference, really. Okay, this doesn't seem too bad. Okay, so let's open up the H file next to me. So right, I think there's a lot of things that I can actually get rid of here now, which is great. But let's. So I need this one right here, right? So read valid source code point. We just pass in the arena, which is why I don't have it in the assert, because this will check it for me. And we just pass in the file. And actually, that probably means I do not need to check for file as well, because this function is already asserting that for me, I hope. So let's just assert the token. We have a code point. This will fail if it's an invalid code point, right? So at this stage, we know if we actually reach this point, we always have a valid, well, valid in my sense of valid code point, right? So the first check would be to see if we are at the end of the file. So code point is, what did I name this? Just end of file. I could have just checked for 0, whatever. But let's be nice. If we are at the end of the file, then the token, this is why I had this open, because I don't remember what I added in there. So we have the token type, which will be token type end of file. What? Not GBA. Why are you doing this to me? And then we have right, so the position would be the position in the file, which is a bit annoying because it needs to be the position before I started reading. Okay. So token position equals file position. Right? Then we have the length. Which in this case is just well, the length of the characters really, right? So so token length is file position minus token position. It's a lot of copying around. Okay, I'll just leave it like this for now. Maybe I can make it nicer at some point. Maybe not with an early return. I'll have to see. Let me just type it out stupidly, and then I can take a look at it again. Okay, so if we have end of file, we set the token type to end of file. The position is this, which is right. Okay, then we have the line and the column. Okay. Probably can have a macro for these things, because that's quite common operations, I suppose. Okay. So that is basically that. And you know what? I might actually just have else ifs in here and do it this way, right? So else whatever, and then in the end we do this. So then I check for a new line, and I no longer need to do this CRLF check, because we're already doing this in the read valid source code point. So if what did I name this? Is code point new line. Cool. Man, my memory, honestly. Code point. So we no longer need to do this, right? This will be correct as well because, well, file position advances right in here. So then token type here would be token type new line. That new line already counts in the next yeah. Okay, I don't know how I feel about this, but okay. So within a line, if we reach the new line character, then that new line character token already counts as if it was in the new line itself. I think that's okay. Yeah, that's fine. It's just a new line. Let's not overcomplicate this, right? Okay, so then I'm checking for white space. Is code point white space? Then we do a token type token type white space. Why do you prefix this with GBA all the time? It's no longer named GBA. Is it just because I have it in this file still? I don't know. Whatever. So, and because white space is a bit special, well, I treat it special. I do not just want to read one white space and then, you know, have like, I don't know how many white space tokens. I just want to conflate them all together. So I'm just looking for the end of a white space run right here. This is what this function is for. And we already determined that the return is absolutely useless here. So what I'm just going to do is this, right? And I don't know what I'm going to pass in there just yet. We'll figure it out. Let's call this read white space. White spaces. Sequence? Read white space sequence? Yeah, whatever. Okay. And however much we're reading here will also be correct with the length, because file position advances of whatever we'll be doing in here. And, okay, the line number, right. No, that's still correct. There won't be a break in between because this reading whitespace sequence actually accounts for that, I think, I hope. That's what I did. Let's check find end of whitespace. So we're reading the com point, we're checking if it is a whitespace, and if it is not, then we stop. Okay. So if that would be a new line, we would already stop. Okay, that's cool. But I now see an issue with that, because this is advancing the file pointer, so I might have to rewind later. Update column. Column is being updated here as well, so I think that should be fine as well. Oh no, we need to have the start of the... yeah, I see. Okay, really what we want is then set this before everything, right? No. So the column... At the moment, the column starts with 0, right? Okay, I'll leave it like this for now. And I will try and figure out the column stuff later. I have to have a think about that. But for now, I'll just update it first and always point to the first column before reading this one. So it is what it is. So here I'm setting the type. Here I'm reading the whitespace sequence, and then then line itself. Actually, I should do this. Okay, fine. Okay. Right, so this is the whitespace. Cool. Then I was checking for digits. Is code point digit? Did I name it like that? Oh my lord. What did I do? Yeah, just this code point digit. Okay. So then we have token type. This is gonna be wait, so I'm reading a digit. Right, and I'm reading as long as the token is. Okay, yeah, that makes sense. So we set it to a number. And then read... no, it doesn't have to be... Okay, so this is, again, something, where do I want to put validation in there, right? I think I will do the validation later in the parsing. I could either be really strict now and just read numbers. And if it is not a number, set it to something else. But since I'm just copying what I already had, I'm just going to say read end of token. So this way, a name could start with a number, and then there could be just some garbage in the end. And then when I actually pass the number, I will, report an error on this one. But as a token itself, we just assume it's a number token. It might be an invalid number token for now, but it is what it is. Okay. So then what was I doing next? And then I went into the single digit tokens. So these ones. Yeah, so these have multiple. Yeah, fine. Whoops. Actually, can I change this formatting because I despise that? Better. So GBA token is really just token type. No, token CP. Okay, so then comments. Those are kind of special as well. That is it did not make any sense what I changed down here. Oh god. Okay, token type comment. And then read end of line. Separator. What is a separator? Just a comma. Cool. Don't forget the breaks. This is in direction. Right. No, that was correct. My god. Okay, these are again for numbers. So negative or positive prefix, so plus or minus. A hexadecimal prefix, which is this $sign. And then for binary numbers, you have to prefix them with the percentage. Those can be anything you want, really. It's just what I liked. Although this $sign is also used in the official Game Boy assembly syntax, I think. But really, we can change that to whatever. And then read end of token, right? Didn't put the brakes on here. You know what? Let's just... I prefer those braces and switch statesmen, so I'm just going to add them now. Okay. You know what? So then we have label, token type label. Fantastic. Token type directive. Those are just single ones, and a string. And here we say read end of string. Ah, come on. Oh, man. And then the default is just whatever. It could be like a user-defined symbol or anything, really. It's just something that we don't recognize what it is. So I just call them identifiers because, like, it could be either the name of a label, it could be a name of an alias, it could be just gobbledygook, right? Some garbage the user typed into the source file, whatever. So let's just do that. What? Oh. I was wondering why it... Okay, that looks nicer. So... read end of token. That's what I want. Okay. So, that could be it. One thing I might change later on, maybe in the stream on Wednesday, is things like labels, right? So now the label token is just a the color, right? So how do I show this? Where are we? Here. So this is what a label is, right? And at the moment in the old assembler, what it would report is, well, it would give you this as an identifier, and then it would give you this as a label, right? So a label token. But then you would basically have to check whenever you have an identifier, you have to peek the next token to see if it is a label token, right? So it's 2 checks you have to do. And then you know that this is a label and not just a simple identifier like here, for example, right? But I'm not sure I like that. What I might do instead is make this one single token that's called label. But that basically means I should not... Well, this would become an empty label, essentially, right? So if you just have that token character. But here, when I read an identifier, so I know I have an identifier, I just read the identifier up to the end. But if I find the label token at the end of it, I just transform it to a label token instead of the identifier. I'm not sure if that makes sense of how what I'm saying here. I'm probably rambling a lot, but basically the code gets quite ugly. I can show that to you like here in the parser, right? Okay, I'm in the parser. Where do I... the parser code is massive. I mean, it's what, almost 3,000 lines of code. And if I can slim that down a bit, that would be grand. So here, if I have an identifier token, right, I peek into the next token if there is one. And if the next token is a label, then I parse this identifier as a label. Otherwise, I just parse it as an identifier itself. And then the identifier could be multiple things, right? It could be an alias, in which case I need to resolve the alias, see if this identifier is within the symbol table and actually specified as an alias and all this kind of stuff. So, yeah. And it also makes it a bit annoying because, let's say in instances like, where is it? So like here, if I would do this, right, this is basically not allowed because this is a label definition as an operand, which shouldn't be possible. So I would always get like a wrong token right here, and it's kind of annoying because I still parse the whole identifier and try to resolve it and things like that, and only after I resolve this I can then see what comes after it and whether it is an invalid token or not. And it would be nice to just flat out reject this altogether without going through the whole thing of like parsing this and adding an unresolved identifier or whatever, even though it's actually garbage. I'm not sure if that makes sense, but you know, apologies if I'm rambling a bit, but yeah. So I'm going to think about that a little bit. Probably also when I add, so this is another problem, right? I said I wanted to add arithmetic operations for labels, so you can subtract one label from another or add them together, right? To get like the offset number within the assembly file, within the assembly output. But at the moment, every time I see a minus or a plus, I just assume this is a prefix for a number. So I'm just treating it as a number at the moment, which I also need to change at some point. So yeah, we'll see. We'll see where this is going. For now, I leave it as it is because this is what I had before. And okay. So this is the read token function. Now we just need to make sure we have all of these, right? So is code point new line and whitespace we do have, but read whitespace sequence. So this is this one right here. So we no longer need a return. Read whitespace sequence. Where do we want to read from? From the source file, I suppose, right? Correct. And we had a while loop. Why did I do that? That basically checks for the end of the file, which now should just become this. Right? Because we still want to fail if it is an invalid code point. So while code point equals this one. Okay, we also need the memory arena. So the annoying part is the arena is actually only necessary for when an error happens, because we use it for the string formatting, for the message formatting, to put it out onto the console. Maybe I should change that and not use the arena at all and just have a static buffer for error messages and just use that. Because like passing the arena around gives the false impression that this method is actually allocating space, right? Which it really isn't, unless there is an error. So I'm probably going to remove that. The arena really becomes more important later on when we want to store identifiers and things like that into the hash table. But okay, if hang on, if I read this code point now, and it is not a white space, I'm actually overshooting, so I need to rewind the buffer, the file reading position, essentially. So I also need something like this now. So get the current file position, right? While... Actually, you know what? Where is it? Code point is white space. I don't know, I kind of don't like this. Okay, let's not move everything in one line. It's a bit batshit. If is code point is white space is true, well, I don't really need this, but it kind of reads nice, I suppose. So, and if it is not white space, what I need, well, nah, we don't. Nah, let's do this. Position equals file position. So restoring the file position, we read the next code point. If it turns out it is not a white space, then the white space run is over. So we kind of need to rewind there so we can reread that particular code point later on for the next token, right? Otherwise, if it is, we just update the position to the current file position. And there's also this break to break out of the loop, but and if we reach the end of the file, then we just reach the end of the file, whatever, right? The white space sequence is over at the end of the file. So there we have it. Can we make this a bit nicer? I guess we can do a return here. Yeah. That's fine. I guess we're doing a bit of extra work by like reading one past and then rewinding just to read the same thing again, but whatever. Okay, so that is read white space sequence, and we need to pass in the arena and the file. Okay. Then we have, read end of token. Let's just skip that for now, and let's go to read end of line. Actually, read end of token is quite easy. Okay, fine. Let's do read end of token. And we have the source file and again the memory arena. I think they're all just going to be the same, won't they? Yeah, okay. Okay. This will be our base to go off. Right. So a token can be ended by a new line, a white space, or just another token character, right? So all the token characters cannot be part of like identifiers or strings or whatever. But we also need to rewind with that. Okay. So if is code point new line, is code point white space, or is code point token. Then file position equals position and return. Right. I like this. It's a lot smaller. It's nicer to read. I like it. Whether it works or not, that's a whole different story. Okay. Let's find the end of the line. So, what did I call this? Read end of line, right? Yeah. And we just need this. Sweet. And we have this as our base. Now, this we don't need to do. Okay, I'm just reading until I reach the end of a line. So, is code point new line, code point. Then we're gonna rewind that one and return. Sweet. And then we have end of string. So this is a string sequence. Now, and this is the annoying part because this one can actually fail, right? So, I mean, in the past it failed. With the error string has not been closed properly, right? Or we got an invalid escape character that wasn't allowed because I only allowed like specific ones. And I don't quite know how I want to handle that. Okay, this confuses the hell out of me. Actually, I only allowed quotation marks as escape characters. Interesting. I don't know why I made that decision. Ah, no, it actually makes sense, but why do I test for other escape characters? That should not be part of this function, I believe. I think this is something that belongs into parsing, where I'm actually going to check whether this string is in the format that I want it to be. I mean, there could be multiple ways, right? So for one, I need string sequences for include files like this, right? So if I have like include me this hardware, like include file, whatever, right? That can be a path. That is fine. And I can use whatever characters, right? I can also use Unicode stuff in here, right? That should be valid. But then, for example, there is a special case with header data. So every Game Boy ROM has like header data that you can provide, right? And one of them is, for example, the game title, right? So you would want to be able to write the game title here. Let's say, for example, Mario, right? But this one only accepts specific characters, so a smiley would be illegal here, right? So it doesn't make sense to test that for every single, or have two different string types, right? Doesn't make sense. So I think validation should just happen somewhere else. So I'm going to take that out of here, I feel like. Read end of string, because I don't really want any of these to fail. The only reason these should fail is if we find an invalid code point and then we just completely terminate anyways. Okay, so let this be our base. Okay, so if it is a code point new line, then this string sequence will end. I won't allow multiple line strings. I don't really see the value for that at all, in an assembler at least. Like, and then, I mean, to see if the string is properly closed or not, the validation just needs to check the length of the string and just check the last character, right? And that's it. Like, is there a quotation mark? Well, the last two characters, because a quotation mark can be escaped. annoyingly, so I do want to allow this kind of stuff. No, that can never happen, really. Because why would you end with a... Yeah, okay. That still works. Sorry, I'm rambling. So if we have a new line, we're done, right? And... Right, so... So if code point is a backslash, I want the next code point, which is just going to be this one. And if honestly, either way, I just accept the next character. Right? So whatever comes after the backslash, I'll just accept no matter what. I just need to read it. That's it. And if, I mean, I could make a little check right here. If it is end of file, I can specifically return, right? But otherwise, I'm just going to check if it is a quotation mark, and if it is, I actually reach the end of the string. In which case, also just return. Code point. Seems fine to me. Cool. And that is the tokenizer. Excellent. Now I need to test it, but can do that real quick in a bit. The rest is like peek and fetch and stuff like that, and initializer for this tokenizer struct, but I don't really need the tokenizer struct anymore because I don't have the separate file locations and stuff like that. So on the next stream, I think I'm in a good position to then translate all the parsing code, which will be fun. Okay, but let's test this. First of all, build, right? Okay, we can build. That's a good start. Now let's use it. Program. Okay, so we need a token, right? Let's init it to 0. Why not? Doesn't really matter. I think we have while. Well. Right. So do read token. Nope. Where is it? This one. I mean, I don't really need to put it in the header file, but I'll just do it anyways. Okay, so read token. We give it the arena, which is annoying. We can definitely get rid of that, and then we give it the source file. And then I'm just going to get the address of the token to fill this in, right? So we no longer have a Boolean return value, which is completely fine because the token will tell us if we are actually at the end of the file or not. Here we could print out the token, right? And then we want to continue reading if token type is not token type and of file, right? Yeah. I mean, you can also just write it like this, but I like to be explicit, so, you know. Right. And then let's print out the token. Why not? We can defo do that. But I do not want to. I do not want to overflow the arena, so I'm actually going to give back the buffer after filling it. So hang on, I have to remember how to do this. There is get memory arena position, right? So this gives us the position before we call stuff. And then we can rewind to that position. There you go. This is a way to reuse buffers in arenas, essentially. Although I could actually make it even better because I have a string format buffer function. But nah, let's just go ahead. Let's just do this. Right. I don't know. Token string. Right. Okay. What do we want to print out? I mean, I guess we want the token type, right? Let's do it like so. Token type. Token. Let's do this. Whoops. Ah, damn it. Right. Let's just call this EOF. New line, white space, comment, separator, indirection, number, label, directive, identifier, and string. Find a default if you must. Unknown. Okay. So then we can make this a string instead. So let's print the token string, right? So token type. I mean, let's just print out everything, whatever. Okay, pause, len, then we have line and column. I mean, this is just a test anyways, right? Okay, so token position, token length, token line, and token column. What did I screw up? Why are you complaining? Because of this. Okay. And there needs to be a comma right here. Then we print the token string, rewind the memory arena, check the token type. If it is end of file, we're just gonna go out and then print the lines. Okay, cool. Build. Damn it. What? Huh? Oh, okay. So here, one mistake I did is it's not a pointer, right? So it's just a dot. Okay. Wait, 3.8. All right, down here as well. Excuse-moi, what? Oh, is it just... No, rewind memory arena to position. Did I just find a bug in... Yeah. Cool. Turns out my header was wrong, so... Oops, I need to fix that. Hang on. There we go. And I probably also need to fix that in my GB header extractor. Because they all use the same header. There we go. No. This one. Okay, cool. Right. Okay. No, what? Wait. What am I doing? Oh my god. I use this down here as well. Shoot. Yeah, just down here. Ah! Okay, cool. But what on earth is going on here? Are you telling me token type is already used? Is that it? Are you serious? I don't use this anywhere else. No. Okay. Yeah, so cool. I guess token type was already used. Let's see. I do have this workspace right here where I can search for Windows stuff. Well, will you look at that? It is specified in winnt.h. Token-specific access rights, so security tokens, I suppose. Gotta love C. I wish it had namespaces. Would be way nicer, but hey, it is what it is. Okay, run. There we go. And that's exactly what I wanted to achieve, right? We have a stream of tokens. It gives the byte position. It gives the length of the token. It gives the line the token is in. And the... hang on. Hang on. Did I just screw something up again? Did I double the lines again? How did I do that? Whoops. Okay. CLS. Run. Let's just see if this at least works. Okay, we have a comment that is 5 bytes long, right? And this is on line 1. This so far is correct. Another comment here. So we have a new line and position 5. Yeah, length 5, position 5 makes sense. It's length 2 because it's CRLF, because it's Windows. Well, that gets reported as line 2, which is obviously not... Ah! Right. I see what happened. So every time I'm rewinding, when there's a new line, I also should have updated the new line and rewind that, which obviously I have not. So if code point is white space, oh, and also the cotton, this is super annoying. No, I didn't want to. Yeah. I see what you now mean in the chat with update column. So really, you need that. Oh man, no, this is... Big sigh, yes. A very big sigh. This is super annoying. I have to think about something better for this one. Okay, so the best part probably would be to have some kind of rewind mechanic built in, right? Rewind by one code point, and then... And since this is not multi-threaded, I can actually just do this in the global or something. Or I could store the last red code point in the struct itself, and then rewind that way. Okay. Well, that was that made it even worse. I fucked something up. I forgot the return. There we go. That's more like it. Okay, 169 again, 169, excellent. And now we actually have, okay, this column is like batshit insane. What happened here is I probably rewind the column too much and then it wraps around, right? And because it's an unsigned, yeah. I need to think about this rewind stuff, but I've been streaming for 4 hours and 30 minutes, so I'm going to do that on the next stream probably. But hey, at least tokenizer is working. That's cool. Okay. So all of this we have translated. I like it. And also the file stuff, to be honest. And we're going to think about rewinding one character, or maybe peeking ahead, or something along the lines. Maybe I do need a peek for reading the next code point. I'm not sure. I'm not sure on what the best way to do this is. Okay, let's add this in the to-do, right? What should we call this? Let's just do to-do, whatever. Right. So we want okay. Let's just call this. No, let's just call this next. So this is what I have to do next, right? Think about rewinding or peeking to the next code point, because at the moment there's some ugly decrements of values going on in the tokenizer, which I do not like. That is all this stuff right here, right? So the rewinding. The other thing is remove memory arena from tokenizer. Remove, yeah, sure. Remove memory arena from tokenizer. It is only used for error messages. And the only way it can fail is by terminating the process. So we might just do something plain stupid there, like just allocate a fixed buffer on the heap in that moment, because we're terminating the process anyways, right? I'm not sure if I want to use a static buffer, because I'm compiling without the C runtime, and I specifically set the stack to be 1 meg. And I like to use the stack only for like function arguments and all that kind of stuff, and local variables and things like that. So allocating like a buffer on there, even if it's a relatively small one, I don't know if I specifically like that. And if I do not allocate on the heap, I might also run into the situation where maybe the stack is almost full and then it won't grow anymore because I gave it a fixed size, right? And then you have other issues as well. So I really might just do a heap alloc for that. I don't know. I mean, hang on, what am I talking about? If I allocate on the stack, it's going to be on the stack already anyways. That's literally what the compiler is doing for me. Why do I even worry? Never mind. I'm talking nonsense. It's all good. All good. Basically, we can remove the memory arena. It has no useful point whatsoever, and it's only used in the error path, and that tells me it shouldn't be passed around, really. So I'm going to do something else for the errors. So that is the next step. What else? Think about token buffers. Circle buffer, maybe. Right? We want to hold on to a specific amount of tokens. Yep. Okay. So this is next. Then let's call it sometime. Write tests for Unicode source files. Does the parsing actually work correctly? Right. I'm just going through this to see if there's anything else. I'm not going to write these things like read command line options because, yeah, I know I need to do that. I mean, that's part of the final program, right? I'm going to get there anyways. That's not something I can forget. I mean, there's error codes here, but yeah, okay. Define proper error codes for non-Windows errors that can terminate the entire process. Because that's something that can happen, right? Those are the library things. Do not need to look at those. String, I do not really need to take a look at. Okay. Console, do not really need to look at. I have a fixed buffer here, so like... Yeah, I'm just going to use a fixed buffer for errors. That's therefore use fixed buffer instead. All right. That's it. I think I'm going to end the stream here. Overshot of by 40 minutes of what I initially wanted to do. I definitely need some food now. Hey, thank you for the follow. Yeah, didn't know I displayed the follow messages actually. I should probably adjust them somehow. It kind of offset, kind of bothers me. Okay. I'm getting distracted again. Anyways, I'm gonna go eat something and then, well, based on the schedule, the next stream will be on Wednesday. Also 10 a.m. I think for, again, 4 hours or something like that. The recording will be uploaded on the VOD channel, which I have linked in the channel description if you want to check it out. I'm probably going to upload it tomorrow, though. Maybe tonight. We'll see. And then guess I'll see you guys next time. If there's any questions, now's the chance. Otherwise, I'm just going to end it. I'll wait for a few minutes. I should say a minute. Thank you, IO means life. Bit twiddling hacks. It's a useful resource if anyone needs that. I definitely want to utilize this. This is kind of cool. It's a way of non-branching checks for a 0 byte within a word. So at the moment, as you see, I'm going through byte by byte or try to read an entire code page, but I also do this byte by byte. And I kind of want to change the parsing of it so I can do this one word at a time, which is kind of cool. I'm not sure if that is useful or not, but I guess I would have to measure performance for that. But I think it could help with like things finding like the end of a line, for example, because you just check for the end of line character, but you check it in chunks of like, 8 bytes at a time, which is kind of cool. But yeah, haven't played around with this yet. Well, okay, it seems there's no questions, so I'm just going to end it here. Well, thank you guys for watching, and see you Wednesday, 10 a.m. UTC time. Where's my end button? There we go. Bye.